Hello and welcome to the video about the different types of energy. Before we get into what all these types are, let's talk briefly about what energy is. Energy is basically the ability to do work. So if an object has energy, it has the ability to do work. In physics sense, that means it has the ability to move something, to carry it from one place to another, to cause it to slow down, to cause it to change its position in any way, shape, or form. Energy is measured in joules. The abbreviation for joules is a capital J, no lowercase j, just a capital J, and it is the same thing as a Newton meter, which we know from before would be the same thing as a kilogram meter squared per second squared for units. And depending on what the situation is, you may see the units coming out like any of those, and that's a good way to check to make sure you actually solved for energy. So now let's take a look at some different types of energy. There are multiple types of energy. We're going to really focus on the first two that I've got listed here, but I want to talk briefly about the others as well. Kinetic energy is the energy of motion. So in order for an object to have kinetic energy, it must be moving. Particles always have energy, so within an object, even if the object itself is not moving, the particles can still have kinetic energy, but we'll come back to that much later. We also have potential energy. Potential energy can be broken up into a couple different kinds. Potential energy is basically stored energy. And there are a couple of different ways that we're going to focus on for stored energy. The first is what we call gravitational potential energy. This is energy due to position within a gravitational field. So we have to assign a 0 point for potential energy so we can know, based on this ground level, how much potential energy do we have if we're above the ground, how much potential energy do we have if we're below the ground. We also have elastic potential energy, and elastic potential energy is due to a spring being stretched or compressed. With each particular spring, we have to know something about it in order to be able to find out how much energy it has in it, whether we're stretching it or compressing it. And that thing that we need to know about is called K, and it is the spring constant. And it is basically a measurement of the stiffness of the spring. Now, when we take a look at these three types of energy at the top here, the one kinetic and two different types of potential, there are equations that go along with this. Kinetic energy, I typically write E sub k, sometimes I write Ke. It doesn't matter which way you want to write it, it's up to you. And it is equal to 1/2 mv squared. Potential energy, gravitational potential energy, because it's due to position. And again, you can write it E sub p or Pe, it does not matter. It is mgh, h being the height above your ground point, or you could also call it mgy if you wanted to keep sticking to the x and y coordinate plane. The elastic potential energy is found by a similar formula to kinetic energy, and for this one, Pe, gravitational, usually has a little g with it. Potential energy elastic will have a little e, and it is 1/2 kx squared, where k is the spring constant and x is the amount of stretch or compression that the spring has found. Now, in order for the spring to be compressed or stretched, of course, we need a force. And the force of compression or stretch is equal to K delta x. Delta x, again, being the amount that the spring is compressed or stretched. Sometimes you'll notice that I write the x just as an x, sometimes I write it as a delta x, but keep in mind that it really is a difference of location that we're looking at, so it is really a delta x. We also have chemical energy. Chemical energy is found in the bonds between molecules. We have thermal energy, which is basically the temperature or the heat that an object has or can possess. Nuclear energy is found in the nucleus of elements, and electrical energy, talking about moving electrons through wires and things. And then, of course, we have mass. And as Einstein said with his equation of E equals mc squared, If we have mass moving close enough to the speed of light, we can convert it to energy. So with all of these different types of energy, the ones that we're going to focus on right now are kinetic and potential energy, and together these are called mechanical energy. So when we talk about the energies in this unit, we are going to ignore the other types of energies. We'll come back to some of them later, and we're going to focus on mechanical energy only because we are still going to be moving things and trying to do work with it. Let's look at kinetic energy first. As I said on the last slide, kinetic energy is equal to 1/2 mv squared, where the m is mass, and mass needs to be in kilograms. The v is the speed or velocity in this case, because typically their magnitudes are the same. And it needs to be in meters per second so that our energy comes out to be in joules. Now, notice that the v is squared. With the v being squared, that means that a change in speed has a much greater effect on the kinetic energy of an object than the change in the mass. So for example, if mass goes to twice the mass, so if the mass doubles, then your kinetic energy becomes twice the kinetic energy, because just the mass there is going to be doubled. However, if your speed goes to be twice the speed, in the equation for kinetic energy, the speed is squared. So that means that your twice your speed is going to change your kinetic energy to be 4 times as much as it was before. So it has a much larger effect on it. So let's look at an example here. Okay, let's say that we have a bird, and it has a mass of 500 grams. It is flying with a speed of 1 meter per second, and I want to know how much kinetic energy it has. Super simple, right? We just want to do 1/2 mv squared. Keep in mind, however, we have to change the mass to kilograms. 500 grams is 0.5 kilograms. 1 squared, well, that's an easy one. And this actually works out quite simply, because 1/2 times 1/2 is 1/4, and 1 squared is 1. So we have 0.25 joules of kinetic energy. If this bird goes ahead and picks up a worm, then flies at the same speed, so he now has a worm hanging out of his mouth. If he flies at the same speed, his mass has increased, his speed has remained the same, so his kinetic energy is going to increase. Not significantly, because the mass of the worm is not going to be all that much, but it still will increase. If he then drops the worm, and he's back to just being himself, the mass goes back down. The speed will stay the same. The kinetic energy goes back down. So keeping in mind that in the equation, the speed is doubled, the speed is squared, then you'll have, if you always keep that in mind, then you will not get confused as to the impact of a changing speed on the kinetic energy of your system or your object. Now let's take a look at gravitational potential energy. Gravitational potential energy is mgh. It is height dependent, and so the height must be dependent on a 0 point. This is up to you. You can choose wherever you want for your 0 point. So let's say that we have a hill that is, or a cliff, I guess this would be more like, and the cliff is 15 meters tall. If we have a rock on the top of this cliff, and the mass of the rock is 10 kilograms, we can determine how much potential energy this is. However, the first thing we have to do is determine where our 0 point is. If we choose here to be 0, then at this particular moment, our potential energy is 0. If the rock were then to fall, and we would look at it when it reached here, the height down here would be a negative 15 meters. So the potential energy down here would be a negative 10 times 9.8 times the 15, which is about 1,000, approximately 1,500, negative 1,500 joules. If we don't want to do that, if we don't want to have our 0 point at the top of the cliff, we can do that too. We can change that. Let's say we want to have our 0 point down here. Then our potential energy at the bottom is going to be 0 joules because it has no height. But our potential energy up top is going to be mgh 10 times 9.8 times 15. Notice that numerically the potential energy is going to be the same whether we put the 0 at the bottom or 0 at the top. If we chose 0 to be in the center, we'd get a little bit screwed up and it'd make life much more complicated. But it will just be the magnitude is the same, and just whether it's a positive or a negative value is what's going to change depending on where we put the 0 point. So for gravitational potential energy, keep in mind that you have the power. You have the power to determine where the 0 point is. So always determine where your 0 point is first, because that will determine whether your potential energy is going to be 0 or is going to have a positive number value or a negative value. We will get into some more details about more difficult problems with kinetic and potential energy in the next video. Bye for now.